And here we want to show that the limit of the quotient, the square root of x squared minus x, divided by 5x plus 1, as x approaches infinity, positive infinity, that this is equal to 1/5. And so again, for this type of problem, with the limits and then finding limit as x approaches infinity, look at the bottom and then find the x with the largest exponent. So in this case it's just x, so we'll divide everything here by x, and then divide everything on the top by x. Now the bottom is easy because 5x dividing by x is 5, and then 1 dividing by x is just 1 over x. And then the problem now is because this is under the square root, but this is not. And so we have to convert x to the square root. And so earlier we saw that the square root of x squared, this is and then earlier we saw that the square root of x squared is equal to x if x is approaching positive infinity and is equal to negative x if x is approaching negative infinity. And so in this case, the x is approaching positive infinity, and therefore in the place of x, we need the square root of x squared. And the reason we need to see this, because if x were to approach negative infinity, then in the place of x, we must have negative square root of x squared. And so now this becomes this. Now that we have square root with square root, then we can divide x squared dividing by x squared. Square root of x squared dividing by square root of x squared is 1. Maybe we need to write it like this, combine them. So we have x squared divided by x squared, and then minus x divided by x squared. So is this x squared divided by x squared, and then minus x divided by x squared. And so now this would be 1, and then x divided by x squared would be 1 over x. And now we're taking the limit, and then we have the square root of 1, and then as x approaches infinity, 1 over x will approach 0. And then here we get 5, and then minus 0. And then the square root of 1 is just 1. And then the bottom we get 5. And so we have shown that it's equal to 1/5.